Today we are going to discuss three topics, that is model for network security, and then model for symmetric encryption, and then model for asymmetric encryption, you can also call this as key symmetric key encryption. The other names are one key, and for asymmetric encryption it is two key. So now we'll see how the model of network security looks, right? So here you can see there is a message, and this particular message will be converted to secure message. Okay, secure message. So using two parameters you are going to convert message to secure message, that is secret information and then security related transformation. So with these two parameters you are going to convert message to secret message by sender, and this particular secret message will be transferred through the information channel, and this particular information channel will be transferring the secure message, and finally you'll get the secure message here. This is done at the receiver side. So here the same process you are going to apply to get back the message, and the two parameters that we have used is secret information and security related transformation. So same parameters you are going to use here. To get back the original message, right? So now the importance of this is who's going to give this particular secret information to both sender and receiver. That we call it as trusted third party. So he is the person who is going to give the secret information to both sender and receiver, and using this secret information and security related transformation you are going to convert message to secure message and secure message to message, right, at both sender and receiver side. So there is a chance that the opponents will be trying to access this information channel in order to get the data. So opponents are something like hackers, crackers, and then viruses, worms, in order to get the data. And if they try, they will get only secure message, which is unintelligible form. Okay, so this message we call it as intelligible form, and this is unintelligible form, so that if you try to read the secure message you will not understand what is the actual information in that secure message. Okay, so intelligent form is something like human readable, whereas secure message it is unreadable by human, right? So this particular process of converting message to secure message using secret information and security related transformation, this whole system we call it as model for network security, right? So who's the trusted third party wins here? Arbiter and distributor. So these are the people who are going to share the secret information to both sender and receiver, and in the general terms we call the secret information as a key and security related transformation as an algorithm that you are going to use in order to convert this message to secure message. So this is the figure for model for network security, right? So by this we have completed topic number 1. Now we are going to model for symmetric key encryption, which is also called as one key encryption. Okay, so here you can see that here I am going to do I'm going to draw the diagram for model for symmetric key encryption and decryption algorithm, which we call it as one key, right? Or other name for symmetric key encryption and decryption algorithm is conventional encryption and decryption algorithm, right? So this is how the terminology that they are going to use for symmetric key encryption and decryption algorithm, which we call it as one key algorithm or conventional encryption and decryption algorithm, right? Now we are going to see how the diagram looks like, right? So here we have seen already the model for network security, where you have seen message, secret message, security related transformation, secret information, opponents, trusted third parties. So all this will be now you can see in a precise manner, right? So here the concept is, we call it as plain text. So plain text is an intelligent form where humans can read it, right? And this particular plain text is given to an encryption algorithm, right? And this particular encryption algorithm will read the plain text and it will convert that to ciphertext. So who's doing this process? That is the sender. So sender side, he will take the plain text, which is intelligible form, he will give it to the encryption algorithm, and he will convert that into ciphertext with the help of a key. So this key I'm going to represent like this. It's a key, right? This key we call it as secret key or shared secret key. Generally there are different terminologies that we are going to use for this key, that is secret key or shared secret key. And this key is going to make plain text to ciphertext with encryption algorithm, right? And this particular ciphertext is transferred over a communication channel, and that will be delivered to a receiver, and receiver will be getting ciphertext, which is unintelligible form. And this fellow, the receiver will be using the decryption algorithm using the same secret key, he will convert the ciphertext back to plain text. So this is the general procedure that you are going to follow in model of symmetric encryption, right? Now for this we are going to use this with a formula. So encryption is done at sender side. So what is the encryption? That is converting the plain text to ciphertext with the help of secret key and encryption algorithm. So we are going to represent this with so here we represent it with plain text as P, ciphertext as C, and secret key as K, right? In the same way here ciphertext, plain text and key. Now using this you are going to generate a formula for encryption at sender side and decryption at receiver side, right? So what is encryption? You are going to get the ciphertext with the help of encryption E, and this is decryption. So encryption E of K comma P. So you're taking the plain text with the help of a key, you're going to get the ciphertext. So this is encryption at sender side and decryption at receiver side. Here you can see the ciphertext is the input. So ciphertext comma the key, with the help of decryption you'll get back the plain text. So how you are going to get back this plain text? So D of K comma, what is C? C is this. So it is E of K comma P. So here you will get back the plain text. So LHS is equal to RHS at the receiver side. So this is the general diagram and the formula representation for model of symmetric conventional encryption and decryption algorithm using single key, that is shared secret key. So important points here to be noted are, the important components are plain text, encryption algorithm, secret key, ciphertext and communication channel, and formula for encryption, formula for decryption. So we are going to discuss now the third topic, that is model for asymmetric key encryption. So the main important blueprint for this particular symmetric and asymmetric encryption are model for network security. So we have seen model for network security here, and now we have gone to model for symmetric key encryption, that is one key, and model for asymmetric key encryption, that is two key. So we have discussed already the model for symmetric encryption or conventional encryption and decryption algorithm using one key. Now we are going to the third model, that is model for asymmetric key encryption and decryption algorithm. We generally call this as two key, right? So the two key we can also call this as public key. So public key asymmetric key encryption algorithm using two keys. So the two keys are public key PU and private key PR, right? This we call it as public key and this we call it as private key. So in this particular model of asymmetric key encryption algorithm, every user in the network will be having two keys, that is public key and private key, right? So now coming to the topic, here also the same process. We are going to take the plain text given to encryption algorithm. You will get back the ciphertext. So here it is encryption algorithm, right? And what is the key that you are going to use here is private key, right? And communication channel, the same old concept. So ciphertext, and this particular ciphertext is given to decryption algorithm. You'll get back the plain text, but here also we need to use the key. So since we used private key here, right, we use public key here, right? If you use public key, you have to use private key. If you use private key, you have to use public key. So that is the concept here you're going to do, right? Now again the same sender, and here this is receiver, right? So now for this also we are going to use the encryption and decryption formulas, right? So the same old pattern, same old symbols we are going to use: plain text with P, ciphertext with C, plain text with P, encryption algorithm with E, decryption algorithm with D. But here private key, imagine that sender is A, so his private key is PRA. So the same public key for sender A we have to use at the receiver end, so this is PUA. So this you have to follow, that you are using two keys of a particular user, that is sender, right? So PRA and PUA. Now for this particular asymmetric key encryption algorithm, there is encryption and decryption formulas that you are going to write, which are most important. Remember, private key of A, public key of A. So same user, two keys we are going to use in encryption and decryption. So here you can see how you are going to get back the ciphertext, that is C is equal to, how you are going to get the ciphertext, that is encryption of the private key that you are using is PRA, which is private key of sender A, comma the plain text. Hope you got it. So you are taking the plain text and the private key and you are encrypting it, you will get the ciphertext. Now at the decryption side, you are taking the ciphertext as an input, and using this public key PUA, you are going to decrypt, and that you will get back the plain text. Now you can see how to put this particular ciphertext formula in decryption. So that is D of PUA, comma, what is C? C is this. So E of PRA, comma P, and finally you will get back P. So here the point is A's public key and private key is used in encryption and decryption. So that is the reason why you will get back the plain text. So this is the general concept that you are going to use for asymmetric key encryption and decryption algorithm, public key encryption and decryption algorithm. Hope the overall concept of conventional key encryption, which is one key, and public key asymmetric encryption algorithm, which is two key, is clear for everyone, right? So the same components here we are going to use are public key as plain text, and private key, public key, encryption, ciphertext, communication channel. So I wish that you are clear with all the three concepts, that is model for network security, model for symmetric encryption, model for asymmetric key encryption using two keys. The most important thing is these two keys are public key and private key. If you use public key at encryption, you have to use private key at the decryption. If you use private key at encryption, you have to use public key at decryption. So this is an important step in asymmetric encryption. So there are two possibilities, that we can use public key or private key for encryption, and the quite opposite key for decryption. So that is an important point that you have to remember. And this is a model diagram for network security, and then model diagram for conventional symmetric encryption algorithm, and model diagram for public key encryption decryption algorithm. Here, if for example, if you are going to use another key, that is public key, there is other concept that here instead of private key you can use PUB, that is receiver's public key. So this is another option. In the same way, here you can use receiver's private key, so that is PRB. So if that is the case, you are using the public key of the receiver and private key of the receiver, then the formula will be changed to the second category, that is C is equal to E of PUB comma P, and at the decryption side you are going to get the second strategy, that is P is equal to decryption of PRB comma C. So this is the pattern that you have to follow, right? So this is important. So two categories you can solve this problem, right? I hope that concept is clear. That is model for network security, and model for symmetric encryption, and model for asymmetric encryption. So these are very important. These are the fundamentals of cryptography and network security. Hope this act as a blueprint for understanding the algorithms in the coming future, right? The most important things are two: symmetric, asymmetric. Symmetric means one key, asymmetric key means two keys, so that you people have to remember forever. Okay, this is Kalyan Chakravarthy, working as assistant professor in Vignan Institute of Information Technology. Thank you.